Good morning, children. You know how to calculate areas of basic geometrical figures like triangles, rectangles, trapeziums and all. When we consider area enclosed by curves, then those formulas are not useful in that case. There we have to use integral calculus. So here in chapter 8, application of integrals, we have to use the integrals for finding area between two lines or areas under simple curves. So look how to calculate area under simple curves. The first figure, this is the curve, that is y is equal to f of x. Then what is the area under this curve? So for that, draw two perpendiculars from S and R. Then this perpendicular SP and this one is RQ. Let this line x is equal to A and this line is x is equal to B. That means P's coordinates we can write as A0 and Q as B0. Then what is the area under that curve? So that portion only we have to find. So how to find that area is integral area of what we have to find? PQRS. PQRS. It is the area under the curve y is equal to f of x, then bounded by, we can say that it is bounded region. That means all portions closed. It's closed. Okay. So it is bounded by, this curve is bounded by x-axis. One side is x-axis, the other one is the curve, then other two sides are the lines. The lines x is equal to A and x is equal to B. So what is the area? Area bounded by the curve y is equal to f of x, the x-axis and the lines x is equal to A and x is equal to B is integral from A to B. Okay, the smaller is A, the greater one is B. So we can write lower limit as A, upper as B. Then y dx. Okay, y dx. So here A and B, that are x coordinates. So you have to integrate with respect to x. Then y dx, what is y? Y is f of x. So this is equal to integral A to B f of x dx. So this is in terms of x, then we can integrate with respect to x. Okay. So what is this integral A to B f of x dx? Area bounded by the curve y is equal to f of x, the x-axis and the lines x is equal to A and x is equal to B. So this closed portion, this green color portion, that much we get when we calculate this integral. Then the same way, here the curve is x is equal to g of y. So in terms of y, so from C and D, draw perpendicular to y axis to the point A and B. So the lines are y is equal to A and y is equal to B. So what is the area under the curve? Area under the curve. Under the curve, which curve? X is equal to g of y. So area of ABCD is equal to integral. There we take y coordinates. Y is equal to A is the line AD. So what are the coordinates of A? 0, A. And coordinates of B, it is 0, B. So we can take the integral A to B. Then A and B are y coordinates. So integrate with respect to y. So here you have to write x. Then what is x? X is g of y. So that's equal to integral A to B g of y dy. So g of y means in terms of y, we can integrate with respect to y. So what is this one? Area enclosed by or area bounded by the curve x is equal to g of y, the y axis and the lines y is equal to a and y is equal to b. Okay. So its area is equal to integral a to b g of y dy. We can do problems. The first one, find the area of the region bounded by the curve y square equal to x and the lines x is equal to 1 and x is equal to 4 and the x axis in the first quadrant. Okay. So once again, area of the region bounded by the curve. What is this curve y square equal to x? Y square equal to 4ax is the standard equation of parabola. So y square equal to x means this 4a is 1. Then also it is a parabola, and how is that parabola? We have 4 types parabola. Y square equal to 4ax is this way, and y square, if it is y square equal to minus 4ax, then the left side. Then x square equal to 4ay. It is upward like this. If it is minus 4ay, then down. Okay. So here y square equal to x, it's a parabola, and how to draw that? Draw like this. Rough figure is enough. So draw the curve. Then the lines x is equal to 1 and x is equal to 4. So draw 2 straight lines parallel to y axis. Here it is 0, vertex at origin. Then x is equal to 1. So draw a straight line. X is equal to 1 and second line is x is equal to 4. And the x axis in the first quadrant. So we don't want this fourth quadrant portion, only the first quadrant. So you have to shade which is the region. Once again you read region bounded by the curve y square equal to x. So one side y square equal to x, and this is the curve y square equal to x. Then one side x is equal to 1. This line is x is equal to 1 and the second line x is equal to 4 and x axis. So which is the portion? So the portion is that. Okay, that much, that colored portion that we have to find. So how to write the formula? Therefore required area, if you want you can give the name A, B, C, D and all, or required area is equal to integral. So we have to find the area bounded by the curve y square equal to x, the line x is equal to 1 and x is equal to 4 and x axis. So it is integral from the lower limit to upper limit. Lower limit, this point, x axis you can take A, B, C, D. A means it is 1, 0 and B is 4, 0. So integral 1 to 4. Then we have to write y dx. Since this upper limits and lower limits that are x coordinates. Okay. Or the lines x is equal to 1, x is equal to 4. That's why you have to use dx. Then 1 to 4, y dx. What is y? You have to use this curve. Y square equal to x. So what is y? Y is equal to root of x. Plus or minus, we have to take the first quadrant portion. So positive value is enough. So root x dx. And also area is a positive quantity. So negative no need to take. Now we have to integrate. Root x integral Root x means x raised to 1 by 2. What is the integral of x raised to 1 by 2? X raised to 1 by 2 plus 1 by 1 by 2 plus 1, or x raised to 3 by 2 by 3 by 2 between the limits 1 to 4. Again simplify. So 2 by 3 we can take out. Okay. So x raised to 3 by 2 between the limits 1 to 4. That is 2 by 3 into, first is 4. 4 raised to 3 by 2. First upper limit, then lower limit. What is 4 raised to 3 by 2? 4 raised to 3 by 2. 4 is same as 2 square. 2 square raised to 3 by 2. Okay. So 2 raised to 2 into 3 by 2, that is the rule, exponent rule. So 2 cube, that is 8 minus 1. 8 minus 7, 1 is 7. 7 2s are 14. So 14 by 3 square units. Okay. That much area for that shaded portion. Clear? So first you have to draw the figure. Then whatever given in the question, here the curve is parabola, then x is equal to 1, x is equal to 4, x-axis and the first quadrant. So you have to take the upper region only, bounded by one side curve, the other sides 2 lines, and the fourth one is x-axis. So required area is 1 to 4, area under the curve y dx. Then write y in terms of x, then integrate and give upper and lower limits. So we get the answer 14 by 3. Now the next one, find the area of the region bounded by x square equal to 4y, y equal to 2, y equal to 4 at the y axis in the first quadrant. So x square equal to 4y, y square equal to 4ax is the parabola. Okay. Then x square equal to 4ay, this type of parabola. So here x square, if x square, here 4a, instead of 4a here 4 itself, then also the shape is parabola, it is upward open parabola. So we can draw the figure. Figure is important in all these questions. Okay. That is parabola. Then y is equal to 2, y equal to 4. And in the first quadrant, so y is 2, let it be y is equal to 2. And another line y is equal to 4. X-axis. The curve x square is 4y. Now shade the region. Which is the region? Area bounded by the curve, the lines and y-axis. So do you get the region? Shade the region. Okay, that is the region. Now here y is equal to 2, y is equal to 4. Y value is given. Okay, so we can integrate with respect to y. So integral from where to where? Required area is equal to here this a I can write coordinates as 0 2, b as 0 4. So integral 2 to 4. 2 to 4, the formula is x dy, not y dx, here x dy, since we use y coordinates. Now what is x? 2 to 4, x square is 4y, x square is equal to 4y. So what is x? Root of that positive value in the first quadrant only 2 root 5. So 2 root y dy. Now integrate. So which is equal to 2 we can take outside. Root y integral is y raised to, as in the previous question, y raised to 3 by 2 by 3 by 2 between the limits 2 to 4. This 3 by 2 we can take to the numerator, so it becomes 2 by 3. So y raised to 3 by 2 between the limits 2 to 4. So 4 by 3 into 4 raised to 3 by 2 minus 2 raised to 3 by 2. What is 4 raised to 3 by 2? It is 8. 8 minus 2 raised to 3 by 2. X into x raised to half. That is equal to x raised to 3 by 2. Here it is 1. So multiplication a raised to m into a raised to n is equal to a raised to m plus n. So x raised to 3 by 2, that we can write as x into x raised to half, that is same as root x. So it is better you learn this, okay, by heart this. X raised to 3 by 2 is x into root x. So here 2 raised to 3 by 2. So you can write as 2 root 2. Here also 4 raised to 3 by 2. 4 raised to 3 by 2 is 4 into root 4. That is equal to 4 into 2, that is same as 8. So it is 32 by 3 minus 8 by 3 root 2. That much square units. It's the area of the enclosed curve. Okay. Now the next one, third one. Find the area of the region bounded by the ellipse. What is the standard equation of ellipse? Last year we have studied x square by a square plus y square by b square. This is the standard equation of ellipse where the major axis along x axis. So here look the figure. This is major axis and this one is known as minor axis. So this type of ellipse, the equation is x square by a square plus y square by b square equal to 1. Here a is greater than b. The second equation, second type is x square by b square plus y square by a square equal to 1. That means major axis along y axis. So it is like this. Okay, so and this is center of the ellipse. Then from here to here, this end point known as vertices. Okay, so from here to here, that is length of semi-major axis. AB. So OA, that is semi-major axis. Its length is A. And AC is the major axis. AC is the major axis. Here major axis along x axis. Major axis length is 2A. Then OB is equal to, that is semi minor axis. Length is equal to B, and which is the minor axis? BD, and its length is equal to 2B. And foci will be here. Okay. Here it is, we don't want that. So the ellipse, when one equation is given like this, first you have to compare which is greater, a square or b square. A square is greater, so the first type of ellipse. If opposite case, b square is greater, that is x square by b square, then you have to draw the second type of ellipse. So first you have to write what is A and B. So figure is clear. Now look, area of the region bounded by the ellipse. So what we have to find? Area of the region bounded by the ellipse means this full portion we have to find. And we know that all four parts are symmetric. So it is better we can find the area of this first quadrant and multiply by 4. Okay, since area is positive quantity, we can use that way. That is, find the area of the region OAB, then multiply by 4. So, equation is x square by 16 plus y square by 9 is equal to 1. So, what is a square? 16, b square equal to 9. So, a I can write as 4. A is the length of semi-major axis. So, positive is enough. B is equal to 3. So, this A's coordinates. A's coordinates, what is A's coordinate? That is 4, 0. Isn't it? This much length is 4 unit. And what about B? It is 0. B is on y axis. So, first coordinate 0. Then y coordinate is 3. Okay. So, required area is equal to required area. Required area means we have to find A, B, C, D. That is same as 4 times 4 into area of the region OAB. Okay. So, that much is enough. Now, how to find area of the region OAB? Area of the region OAB. So, look, either we can use x coordinates or we can use y coordinates. So, and I am using x coordinate integrals from. So, you have to look only on x axis. From where to where? This is the curve. Okay. So, this region is bounded by this y axis, this x axis and the curve. Here we have only 3 portions. And here the starting is from the origin, that is here it is 0. 0 to 4. Okay. So, integral I can write as 0 to 4 y dx. Or the same area we can write this way also, 0 to 3. 0 to 3 means 0 to 3. So, area under this curve. So, here we are using y coordinates. So, x dy. Okay, either this method or this method. Both will give same answer. Now, what is y? Y dx. So, y we have to find from the equation. This is the given equation. So, from that we have to find y. So, which is equal to 4 times 0 to 4. X square by 16 plus y square by 9 is equal to 1. So, what is y square by 9? Okay. So, y square by 9 is equal to 16 minus x square by 16. Or y is equal to 9 you have to take to the right side and taking the root, it is 3 by 4 root of 16 minus x square. Since it is in the first quadrant, take the positive value. 3 by 4 root of 16 minus x square, that you have to write here dx, or you can use this way. Okay. Now, how to integrate? 3 by 4 we can take outside since it is a constant. Root of 16 minus x square. We have the standard result, integral root of a square minus x square. What is the integral of root of a square minus x square? X by 2 root of a square minus x square plus a square by 2 sine inverse x by a. This is the result that we have to use here. So, the area, required area is equal to 4 times 4 into 3 by 4. So 4 and 4 cancel. Then integral. Root of 16 minus x square, that is x by 2 into root of 16 minus x square plus a square by 2. In the place of a square it is 16. 16 by a square by 2. Sine inverse x by a. What is a? 4. Between the limits 0 to. So 3 into 4 by 2. Root of 16 minus 16. Applying upper limit. Plus 16 by 2 is 8. Sine inverse 4 by 4. Then minus, after applying upper limit, minus lower limit. Put 0. 0 by 2 into root means it is 0 itself. Then plus 16 by 2, 8 sine inverse 0. So 3 into, the first term is 0, 8 into sine inverse 1. Sine value is 1 at pi by 2. Then minus 0. Again sine inverse 0 is 0. So we have 3 into 4 pi. That's equal to 12 pi. So this much is the area of the ellipse. Okay. Once again we have to find the area, bounded area of the region bounded by the ellipse. X square by 16 plus y square by 9 is equal to 1. So first we have to draw the ellipse. There are two types of ellipses. One is x square by a square plus y square by b square equal to 1. One is x square by b square plus y square by a square equal to 1. So in the first case major axis along x axis. Here a square, a value is more than b. So major axis along x axis. So this type of ellipse. Otherwise the opposite. Now we have to find the whole area, that is ABCD. So it is easy to calculate the first quadrant portion into 4. That is enough. So 4 into area of the region OAB. Then OA is length of semi-major axis, that is 4. If a square is 16, a is 4, b square 9, so b is 3. So b's coordinate 0 to 3. You can take either x or y. So here I am taking x. So from 0 to 4, area under this curve. Okay, area under the curve. So formula is y dx. Then y you have to find. From the equation of the ellipse, find the value of y. Then integrate with respect to x. Here the integral is standard integral. So its equation x by 2 into that root plus a square by 2 sine inverse x by a. Then apply the limit 0 to 4. So last we get 12 pi.